Hello everyone. Uh, so this is the lecture number 1 for the first outcome, that is your DC circuits. Now in this particular outcome we will be discussing about the different parameters of an electrical circuit. So we'll start our discussion with the charge. We will discuss about what is charge, current, uh, electromotive force, or in short we call it as EMF. Then we will also discuss about potential difference. After discussing these basic parameters of a electrical circuit, we will move on to discussing about Ohm's law. Right? It's a very widely used law, and some of you must already be aware about it. What is a Ohm's law? And then we will move on to series, parallel, and combination of series and parallel circuits. Right? How do we solve them? After that, we'll discuss about the Kirchhoff law and solve some of the questions related with that. And then we will discuss about voltage and current division. And finally, we will discuss about the energy and power in a DC circuit. So overall, we will try to, learn about the different parameters of an electrical circuit along with how to analyze a DC circuit, right? Now, before I continue with the class, I will just briefly tell you about the arrangement of bright space, so where you can find all the resources. So in your in the shell for this module, if you go into learning resources, you would find the class notes, right, and the tutorial sheet, and also I will upload this video which I am recording, right? So after the tutorial classes, I will make these answers, the tutorial answers, visible for you so that you can match your answers and everything, right? So currently it will be the solution for the tutorial sheet, it will be hidden, right? It won't be visible for you. But once we take the tutorial classes, or during those tutorial classes, these answers will also be visible or made available to you. And similarly, you have the learning resources for outcome 2, 3, and 4. So you can have a look at them. So I've uploaded the class note. The lecture slides will be available, although these are the lecture slides from last year. So I'll be updating them. I'll be updating them with the new slides which I've prepared. Essentially it is the same slide, but I'll be updating them. Then again you will have the tutorial sheet, the solution will be made available, and you will have the recording for the lectures. Right, so you can have a look at them, the learning resources. Now let's continue. So basically in the first outcome we'll be studying about, first of all, about the parameters of an electrical circuit, and then we will move on to discussing about DC circuits and how to analyze them, right? Or find different values such as the value of current or the value of resistance or the voltage which you should apply in a circuit, right? So all that we'll discuss. Now, as we all know that everything around us are made out of atoms, right? So an atom, it consists of a nucleus in the center, and you have electrons revolving around it. in different orbits, or we call them shell, right? So either you can call them as orbits. So these are your different shells or orbits in which these electrons, they revolve around the nucleus. Now the nucleus, it consists of protons and neutrons. Now protons, they carry positive charge, whereas the neutrons, they are neutral, they do not carry any charge, right? And these electrons, they are negatively charged and they revolve around this nucleus in different shells or orbit. Now for a stable atom, the number of electrons and the number of protons, they are equal. So you have some positive charge in the center, and you have some negative charges revolving around this positive charge. So obviously there will be some force of attraction, right? There will be some forces on these electrons which are revolving around this nucleus, right? Because unlike charges, they attract each other, right? So you have the positive charge and the negative charge. So the negative charges, they will be attracted towards the positive, or the electrons, they will be attracted towards the protons which are present in the nucleus. However, since the number of protons and electrons, they are equal, this force of attraction is enough to bind the atom, but it is not that strong so that the electrons, they collapse within the nucleus, right? So that force of attraction will be there, but it is not that strong that the electrons will be pulled in or something, right? Now since the electrons, they would be revolving around this nucleus in different orbits, right? So the outer electrons, the force is acting on the outermost electron, or the electrons in the outermost shell, will be relatively less, I would say, right? So the electrons in the outer shell of an atom are attracted by a force less powerful than those near the nucleus, right? So the electrons which are closer to the nucleus, they will be attracted by a stronger force, whereas the electrons which are in the outermost shell, the force of attraction will be relatively less in comparison to those in the innermost shell, right? So if we apply some kind of force or some kind of external agitation, maybe heated or something, right? So if we provide a little bit of energy, what would happen to the electrons in the outermost shell is you could knock them out, or you could just pull out an electron from the outermost shell of an atom. Now these atoms which you have pulled out of the atomic structure, and they are maybe somewhere here, now you have pulled it out, so now it's free, so they are called as free electron, right? It will have a negative charge. Now the free charges, they are generally called as ions, right? So since this electron is free to move around, this free electron is called as negative ion, right? And the remaining atom, since you have pulled out an electron from the atom, the remaining atom, it will develop a positive charge on it, or it will have deficiency of electron, or it will have more number of positive charges, more number of protons within it. So as a result, it will develop a positive charge, right? So again, the leftover atom is also free, right? So the remaining atom is called as positive ion. Now, since the electron or the negative charge and the positive charge, they are both free, so if we apply a voltage to this, now obviously any material, it will not consist of a single electron within it. You would have multiple electrons within the material, right? So we were talking about a single atom at the moment, but imagine the atoms. Where should I put it? Let's put it here. Right, so we were discussing about only a single atom, but now imagine about the entire material, which will have huge number of atoms, right? So as a result, if you are knocking out one electrons from each of these atoms, you would have quite a sufficient number of uh, electrons in that material, right? You would have quite a lot of electrons in this material. Now if you apply a force, electrical force, that's your voltage across this. Let's say we apply the positive and the negative terminal like this. So what would happen is the electrons, they will be attracted towards the positive and they will start flowing in the circuit, right? So this flow of electrons, or basically generally we should say the flow of charges within a circuit, is called as current. Right? So we could say that the current would start flowing in the circuit if we apply a voltage across this type of a material. Right? Now generally the metals, they have more number of free electrons, that's why they are quite conductive. And insulator, they have very small to negligible amount of free electrons, so that's why they do not conduct electricity, or they are insulators, right? So having discussed that, let's move on to the next topic, or the first topic which we have to study. So the first thing which we have to study, or which we have kind of discussed already, is charge. Now charge is represented by the letter Q. Sometimes you write it as small q, sometimes you write it as a capital Q. Right? So charge is the difference between atom whose outer shell have either gained or lost an electron. So as we have discussed right now, that if you have the atom from which you have knocked out, sorry for the figure, you have knocked out one electrons from the outermost shell, it develops a positive charge, right? So charge is basically the difference between the atom whose outer shell has either gained or lost. Similarly, this free electron, what could happen is they can bind with the neighboring atom or another atom which is present in that substance or in that material. So it can bind uh, with another atom close by, right? So in this case, since the atom was initially stable, number of electrons and protons, they were equal, and this free electron is now getting binded to this atom, it would develop a negative charge, right? So charges basically they occur because of gaining or losing the electrons, right? Now an atom missing an electron is said to be positively charged, and an atom with an extra electron, something like in this case, is said to be negatively charged, right? So this would overall develop a negative charge. Now the charge Q is given by this equation here. Q is equal to the current I multiplied by time t. So current is usually measured in amperes. We are going to discuss about it immediately in the next slide. Uh, but basically the current is measured in amperes and time t is measured in seconds. And the unit of charge is coulombs, right? Or you could symbolize it by capital C. Now just for analogy, 1 coulomb of charge is equal to 6.24 multiplied by 10 to the power 18 electrons. So if we say that a particular material has 1 coulomb of charge, right, or this piece of let's say a metal or something, it has 1 coulomb of charge stored in it, right? That means you have 6.24 multiplied by 10 to the power 18 number of electrons which are present in this piece of metal, right? Now the next thing which we have to study in this first outcome is current. Now current is, you can write it or symbolize it by capital letter I. Sometimes even small I is also used, right, to represent current. Now current, as we have already discussed, it is the rate of flow of charge. Now in the previous slide I've kind of like mentioned it is the flow of electrons. Now here I am mentioning it is the flow of charge, right? So ideally, or the best statement or definition for current is it is the rate of flow of charge. But if we try to elaborate a little bit, you have the electron. So let's say this is your material in which you have knocked out some of the electrons, and you have the atom with the positive charge, right? So you would have the atom, and overall it will have the positive charge because you have pulled out one electron. So this is the condition over here. Okay, now we say current is the rate of flow of charge as the perfect definition, but sometimes we also say that it is the flow of electrons. Why do we say that? Does it mean that the positive charge or the remaining atom will not flow, right? Because you have applied a voltage over here. Why won't your positive charge it will flow, right? Why can't it flow? Now the basic reason for that is since electrons is quite small, right? And the remaining atom will be relatively larger. So if you think about it, the electrons would be much lighter in weight in comparison to the remaining atom. So obviously, the mass which is lighter, it can move very easily. That's why we say that it is the flow of electrons. But the best definition for that is current is the rate of flow of charge, right? It could be either positive or the negative. Anyways, now the unit of current is amperes, and it is represented by capital letter A, right? Um, Now, although it is not mentioned anywhere in your module, in this particular module, but it is always convenient to understand about the two types of current, because outcome 1 is DC circuit, and then in outcome 4 I think we'll study about AC circuit. So what's the difference between a DC and an AC, right? We are studying two types of circuit. Why? I mean, what are they? So just to understand or to discuss a little bit about that, DC means direct current. So direct current is when your current flowing through the circuit, it remains constant, invariable of time. So if you look at the first circuit, the first figure over here, right, this one, figure number A. So at different instances of time, so let's say at 1 second, 2 seconds, 2 seconds, let's say 5 seconds, let's say after 50 seconds, the value of current or the amplitude of current, let's say if it was 5 amperes at 1 second, it will remain at 5 amperes after 2 seconds, and even after 50 seconds the same amount of current will be flowing through the circuit, right? So for a DC circuit, or in a DC circuit, the value of current, it does not changes with time. However, for the AC circuit, now AC, it means alternating current. So for this AC circuit, both the magnitude as well as the direction of current flowing through the circuit, it changes with respect to time. Now if we look at the second figure over here, that's your AC, this one was DC, right? What you could see is it's a sinusoidal graph, right? So if we look at different instances of time, let's say after 1, 5 and 10 seconds, if you look at the amplitude of the current, of the alternating current, it is different, it is changing at every instance of time. The amplitude of the alternating current, it changes. Now along with that, if I redraw it something like this, right? So along with the magnitude of the current, the direction of the current will be also changing with respect to time. So if we look at just the first one cycle of the alternating current, so for the first half cycle, the magnitude of the current, it is changing and it is positive, whereas for the second half of the cycle, the the magnitude of the current is again changing and it becomes negative, right? So the direction of the current would also change. So if you have some circuit or some resistance which you have connected to a alternating current like this, what would happen is for the first half cycle, let's say this is positive and negative, So the current will flow in this direction. Whereas for the second half cycle, since it becomes its polarity, it changes, it becomes negative. So now this will become negative and this side will become positive, and the current will start flowing in the opposite direction like this. So along with the magnitude, the direction of the current would also change for an alternating current. However, both they are current and the unit for both of them will be amperes. Now, the next thing which we have to discuss is potential difference, or in short we call it as PD. Right? We call it as PD, or potential difference. So potential difference is the difference in charge value due to free electrons which exist at the atomic level in a material. Now for explaining this statement, or this explanation over here, potential difference is the difference in charge value. Now we say that the current would flow from a higher potential towards the lower potential, right? So what do we mean by this term higher potential and this lower potential? Uh, so any material is said to be at higher potential if the concentration of charges in that material is more, right? So higher potential will mean higher concentration of electrons, or basically you would have more number of electrons in this material at higher potential. And similarly, the lower potential, it would mean you would have lower concentration of electrons. That means this side of the material, it will have less number of electrons, right? So as a result of this concentration of charges on two different sides, they will develop a potential difference between them, right? And because of that, the current will start flowing. Now just to relate the concept backwards, so current is the flow of charges. Now from our understanding, we have kind of understood that it's the electron that flows, not the positive one, because it's a bit heavier, right? So it will be quite difficult, or you would need more amount of force to push those positive or the remaining atom, right? So it's the electrons which are flowing. Now on one side you have higher number of electrons, right? Or the concentration of electrons are quite high. Now let's say in a room, if we have like in a small room, let's say we have 100 people, they are made to stand or sit in one small room. So what would happen, the concentration of people will be more. Now if we have a room adjacent to that one and you have only like one or two people sitting there, and it's a big room, so obviously the people from the higher density room would like to move to the lesser density or the room with less number of people, right? So that's what your electron will do. In this part of the material, the electrons, they are cramped in. So if you connect it through a wire, all the electrons would like to move to the lower potential, where they have a space to move around, right? So due to the difference in charge values due to free electrons, a potential difference will develop. Now if we cut this wire and zoom it here, right? This here. Uh, so this is your copper wire, and the electrons, they are flowing in this direction, right? So even due to the flow of charges or the flow of electron, uh, the wire will have potential difference. So since the electrons, they are flowing in this direction from left to right, the concentration of electrons on the left side of the wire will be higher in comparison to the right hand side, right? So the left side of the wire will be at higher potential, and the right hand side of the wire will be at lower potential. So because of the flow of electrons also, or because of the flow of charges, a potential difference is developed, right? Either it is inherently, in this case it is inherently, like two different material, they have different concentration of electrons, and if you connect them by a wire, they would the electrons would start flowing because of that potential difference. Or if the charges or the electrons, they are flowing in a wire, uh, there will be a potential difference, right? So basically it is because of the difference in charge value or charge concentration, and mainly due to the free electrons, right? The unit of potential difference is volts. Okay. Now let's move on to the next topic, which is your electromotive force, or in short we call it as EMF. So EMF is the ability to cause current to flow in a complete circuit, right? And its unit is also volts. So both potential difference and EMF will have the same unit, but they are two different things. Now electromotive force is the force which is causing the current to flow, right? You have some electrons in let's say a metal piece, free electrons in a metal piece, right? But will they start flowing automatically? No. If you need some force to make the electrons move, right? Um, let's say if we have a table, it's not going to move on its own, right? You need to apply some force to make it move, right? So that force in electrical circuit for moving the electrons is called your EMF, or electromotive force, right? And its unit is volts. Now since just to highlight the difference between electromotive force and the potential difference, um, electromotive force is the force to do work. That is the cause which uh, the force which causes the current to flow. That's your EMF, right? Whereas potential difference, it is the voltage drop as a result of current flow, right? So this potential difference was developing because of the flow of uh, electrons, right? Or the flow of current was causing a potential difference, and as a result you would have some losses, or you would have some uh, potential drop or voltage drop across the wire, right? uh, Whereas the EMF is the force which you apply to make the current flow, right? One is, just a second, right? So one is your EMF, which is forcing the electrons or the current to flow in a complete circuit. Now, is this circuit complete? No, because it's not uh, going back to the negative terminal here, right? So that's why we write down these, specifically you have to mention that in a complete circuit, right? If your circuit is broken or it is not complete, let's say if your circuit is broken here, right, uh, no matter how much amount of EMF or the force you apply, uh, the current will not flow in this circuit, right? But if your circuit is complete, in a complete circuit, it is the force which makes the current flow, and because of this flow of current, some potential difference will develop and cause some voltage drop across the component which you have connected, or because, across this resistance which you have connected, right? Now the next thing which we have to discuss is resistance, or in short we write it as capital letter R. So resistance, in like literally, also in generally we say it is the opposition. You resist, let's say a cause, or you resist some law or something, right? So you are opposing that law, or you are opposing the cause, right? So it is the basically the meaning is also is quite related here. So resistance in terms of electrical circuit is the measure of a material ability to oppose the flow of current, right? So resistance is the measure of material's ability to oppose the flow of current when an EMF is applied. So again, all these small little things added at the end, they are quite important. So you have, so every material, they would have different value of resistance, right? So resistance is the uh, opposition, or the ability to oppose the flow of current when an EMF is applied. Now if you do not apply a EMF to this component or this resistance, and you say, oh my god, it's quite resistive, right? Or if you have a piece of metal which you have here, and you try to measure the current and say, oh no, it's quite resistive because it's opposing all the current, right? You have not applied the current, so obviously no current is flowing in the circuit. So that's why you have to mention when an EMF is applied to it, right? When you know that the current is flowing, but this metal piece, or this material which you have connected here, or this component, electronic component which you have connected here, is opposing this flow of current. That's called your resistance. Now resistance, it depends upon the following three factors. It depends upon the length of the conductor or the material. It depends upon the cross section area, right? So it depends upon the length of the material, it depends upon the cross section area of that material, and it depends upon the resistivity, right? So resistivity is represented by this Greek letter here, and it is related, or the formula for calculating resistance based on these three factors is given over here. So resistance is equal to resistivity rho multiplied by the length L divided by the area. Now its unit is ohms. Now you might have seen the overhead electrical transmission wires, right? Maybe something like this, right? So the wire, they are used to uh, transmit electrical energy from, or electricity from one city to another, right? So if you might have observed that those wires, they are quite thick, or their cross section area is quite quite large, right? You place quite thick wires. Now if we talk about resistance in that term, obviously we cannot reduce the length. If the distance between two uh, city A, sorry, and city B, if it is 10 kilometers, the length of the transmission wire should be 10 kilometers. You cannot reduce it, right? Now resistivity. So resistivity is the property of a material, inherent property of the material to resist the flow of current, right? For example, gold has uh, uh, the least amount of resistivity, or its resistivity is quite low, whereas if we take aluminium, it has relatively higher resistance, right? So obviously we cannot use gold to make these wires, right? Just to reduce the resistivity. It has to be mm, financially also you have to think about that, right? But we can make those wire a little bit thicker, having a relatively larger cross section area, right? So that's why your transmission wire, they are quite thick, right? So that you can reduce the value of resistance, right? And obviously resistance also, they will cause a potential drop or a voltage drop, right? If you have more resistance in the circuit, you will lose voltage across those resistances, right? Now the next thing which we have to discuss is about Ohm's law. So I'm sure you might be already aware about Ohm's law. You might have heard about it at least, right? Now Ohm's law, uh, generally we say that it relates the it gives you the relation between resistance, current, and voltage, right? So obviously in a general circuit you might have some values, some resistances, right? Some opposition in the flow of current. You might have a voltage source, or we call it, we have applied some electromotive force here whose unit is volts, or right, whose unit is volts. So you have applied the EMF. Because of this electromotive force, some current will start flowing. If the circuit is complete, the current will start flowing, and you would have some resistances in the circuit, right? So it kind of relates all these three parameters. The force, and the result of it is a current and some opposition in the circuit, right? So it kind of relates all these parameters in the circuit, your voltage, current, and resistance. It's given by this equation over here. Voltage is equal to current multiplied by the resistance. Now from this single equation we can develop two more relation, or we can kind of modify this equation, and let's say if we have to find out the value of current, right? So from this equation itself if we have to find out the value of current, in that case it will be voltage divided by resistance, right? Similarly, if we have to find out the value of resistance, it will be voltage divided by current, right? So all these three relation you could kind of understand from this triangle, right? So if you have to find the value of voltage or the EMF, right? Voltage is the unit, right? So your voltage, it will be current multiplied by resistance, right? So if you have to find the value of voltage, it will be current multiplied by resistance. So I multiplied by R. And if you have to find the value of current, then it will be voltage divided by, or EMF divided by the resistance, right? And similarly, if you have to find the value of resistance, this one, then in that case it will be voltage divided by current, right? Okay, so now the exact statement, let's try and understand, of Ohm's law. So Ohm's law, it states that in a uniform wire, so your wire, it should be uniform and there should be no irregularities in the wire, right? So in a uniform wire at a constant temperature, the current flowing will be directly proportional to the voltage and inversely proportional to the resistance. So for, or in a uniform wire at constant temperature, the value of current flowing in the circuit will be directly proportional to the voltage and inversely proportional to the resistance. Sorry. Right? So obviously your wire should be uniform so that you don't lose any power because of the non-uniform wire, right? And different or the same material at different temperature, the value of resistance will be different, right? For the same material, let's say if you have a aluminium sheet or a aluminium wire, and you are measuring the resistance at 0 degrees centigrade, right? It will give you a certain value. Now if you heat it and then measure the resistance across the same wire, it will be different. So the value of resistance, it changes with temperature. Now obviously if you heat a metal, what happens at the atomic level is the electrons, they starts to vibrate. So since the momentum is there, the electrons, they are vibrating, and if you apply a little bit of electromotive force or voltage, the the electrons will start flowing. So that means there is less resistance, right? Because of you have already heated the aluminium wire or something, right? So, and the same material, if you cool it down, what would happen, that you have to, first of all, you have to apply more electromotive force to move the electrons. So as a result, the resistance will be higher, right? So obviously, I mean, to conclude, the same material will have different value of resistances at different temperature. So that's why, to be quite specific, we mention that in a uniform wire and at a constant temperature, right? And obviously from the Ohm's law, you can say that for a uniform wire, constant temperature, the current is directly proportional to voltage and inversely proportional to resistance, right? Okay. Right. Now, before we take some questions based on Ohm's law, uh, we should be aware about the unit conversion, or we should know how to convert the units. So generally we try to convert all the values which are given in a question to a common unit, right, which is your SI unit. Uh, so uh, let's take an example over here. So first we have to, in the first part, we have to convert, oops, in the first part we have to convert 1 milliamperes to amperes. So this is the table for unit conversion. You can refer to that, but it will not be made available during your assessment, right? So you should know or remember these values or how to convert them. So milliamperes here, right? And your amperes will be somewhere here.
Right. So the milliamperes is here. You have the milliamperes and you have the amperes here. You have to convert it or you have to move up. So if you move up, you have to multiply. So 1 milliampere, sorry, if you move up, you have to divide, right? Will be equal to 1 divided by 1000. Or you could also say it is 10 to the power minus 3 amperes. Similarly, if we have like 5 milliamperes here, so we'll have to divide this 5 by 1000, right? By 1000. So it will be 5 multiplied by 10 to the power minus 3 amperes. Now, similarly, in the second part, we have to convert 5 kilovolts. So kilo is here, this one, to volts. Now these are kilo, hecto, mega, giga, centi, milli. These are the prefix. You could have kilovolt or kilo ohms, right? Or kilo amperes even. Okay, so if we have to convert 5 kilovolt, that is, we have to move down, we have to multiply. So it will be 5 multiplied by 10 to the power 3, and that will be in volts. So, like in a numerical or in a question, uh, you would obviously have some formula. So the first step would be to identify the formula which you have to use in that to solve that particular question. The second step would be to apply the values which are given in the question. Now, before applying the values, you should always convert all the units into the same like standard, right? So you can have a look at it. You can practice some unit conversions as well, and I am a little bit sure that at your level you should be already aware about unit conversion, right? Now, so let's take this example over here. Uh, so in this example number 1, we have to calculate the current flowing in the circuit. So we have to calculate this value of current over here. So you are given with the EMF which you are applying, or the voltage source which you have applied. It's of 12 volt. The direction of current is wrong. It should be from the higher potential towards the lower potential. So it should be something like this. I is what we have to find out. So the direction of current was wrong. Anyways, right. So you are given with the voltage, the value of voltage, and you are given with the resistance. So resistance is given to be 4 kilo ohms. So let me write it down. The EMF or the voltage, it is 12 volts, and the value of resistance, it is 4 kilo ohms. Now if you look at these two values, uh, one is in volt, another is in kilo ohms, right? So we have to convert this resistance into SI unit. So it is in kilo ohms, so we'll have to. So we have converted the units, right? And now we can apply Ohm's law. So obviously we have already identified that we have to apply Ohm's law in this question to find out the value of current. So we can modify this equation and write it down as current is equal to voltage divided by resistance. And since we have already converted the unit into the same standard, so now we can apply the values. So the value of voltage, it was given 12 volts and divided by the resistance. So resistance is 4000 ohms, or 4 multiplied by 10 to the power 3 ohms. Now if we do the calculation, it will come out to be 0.003 amperes, and which is 3 milliamperes, right? So it's always convenient to write it in the appropriate or in the smallest unit possible, right? So it's quite, I would say a little bit unprofessional to mention that the value of current flowing is 0.003 amperes, right? Just stating that it is 3 milliamperes is more professional in a way, right? Now, in this practice question, which we have taken in the class, or which you were required to solve, you have to find out the missing values of current, voltage, and resistances using Ohm's law. So you have three circuits over here: circuit A, B, and C. Now, again, we have to apply Ohm's law for calculating all of them. In the first circuit, or circuit A, you are given with the value of voltage, which is 12 volt. The value of resistance is 6 ohms, and you have to find the missing value. So the missing value is here is current, right? So you have to find the value of current. Now we have the triangle over here, so we can directly write the equation for current. It will be voltage divided by resistance R. Now, do we need to convert any of these unit? I don't think so. Both are in SI units, right? So the value of voltage is 12 and the value of resistance is 6. So the value of current, if you solve it, it will come out to be 2 amperes. Similarly, in the second circuit, or in circuit B, you are given with the value of current, which is 4 amperes, and the value of resistance, it is 3 ohms. And the missing value you have to find out, which is your voltage, you have to find out. So again, we can use Ohm's law, and using this triangle, we have to find out the value of voltage. So voltage, it will be current multiplied by resistance. Now, before using these values, just ensure that you don't need a unit conversion. So current is given in amperes, resistance is in ohms, right? So you don't need to convert the unit. We can directly use them. So 4 multiplied by 3, which is 12 volts, right? So while solving any numerical, just don't miss out or skip any steps, and don't forget to mention the units. If you uh, miss out any step, or if you forget to mention the unit, you will lose some marks, right? Now, in the third circuit, or circuit C, let's do the calculation a little quickly. So the value of current is given 3 amperes. The value of EMF, E, or the voltage is given to be 12 volts, and the value of resistance is missing or unknown. We have to find that. So now from the voltage triangle, we have to find the value of resistance. So the value of resistance will be voltage divided by current. So R will be equal to V divided by current. So voltage, do we need unit conversion? No, this current is in amperes, and the EMF or the voltage is in volts, right? So no need for unit conversion in this question. So voltage is 12 divided by the value of current is 3. So if you solve it, you would get 4 ohms. Don't forget the unit. Sorry for that. Yeah. Okay, so you can try and solve it yourself and match the answers. Now, all right. So the next thing which we have to discuss in this outcome is resistances in series and in parallel, right? So the resistances are said to be connected in series if the same current flows through them, right? So if you have something like here, if you have three resistances connected, and if the same current is flowing through all of them, that is, the current is not getting divided, right? There is no another path for the current to flow. It has to flow through these three resistances. So the value of current will be the same, right? So in such a case, you would say that your resistances, they are connected in series. And to find the total resistance or the equivalent resistance, what we do is we simply add these three resistances together, right? So the total resistance will be equal to R1 plus R2 plus R3, right? So in the given circuit, the value of R1 is 2 ohms, the value of R2 is 4 ohms, and the value of R3 is 6 ohms. So let's write it down. 2 ohms plus 4 ohms plus 6 ohms. So altogether you would get 6 and 4, 10 and 2, 12 ohms. So the total resistance of the circuit, or the equivalent resistance of this uh, circuit, it will be 12 ohms. Now the reason why we try to find out the equivalent resistance is that instead of the three resistances or three separate resistance, since we have calculated the total resistance or the equivalent resistance, we can replace the three resistances by a single resistance, right? With a value of RT, or R total, right? And its response or the circuit behavior will be the same as the previous circuit, right? So the same value of current will be flowing in the circuit and everything else, right? So sorry, generally we usually have quite complicated circuits, right, given to us. And if we are asked to analyze that circuit, find out the voltages and the current flowing in the circuit and all, it uh, it is quite complicated. So as a electrical engineer, the first thing which we try to do is to reduce the circuit. Or even while designing a circuit, right, uh, you may add like three different resistances in the circuit, but it's going to make your circuit a little bigger, right? uh, but obviously we all require smaller circuit, right? So while uh, uh, studying your circuit or while designing something, you can reduce it by replacing three resistances with a single resistance with its equivalent value. Now, in a series circuit, the value of current flowing through each resistance will be the same. However, the voltage across each of these resistances, or the potential drop across each of these resistances, will be different, right? So you would have V1 across R1, V2 voltage appearing across R2, and V3 voltage appearing across R3. And you can use Ohm's law to calculate these values. But the interesting part is if you add all these voltage drop across these three resistances which are connected in series, you would get, or you should get, uh, or it should be equal to your supply voltage. That is, the voltage drop across each of the resistances connected in series. If you add them up, you should they should be equal to the supply voltage. Okay, so V1 plus V2 plus V3 should be equal to Vs. Now, resistances in parallel. So we have discussed about resistances connected in series, and now let's discuss about the resistances connected in parallel. So in a parallel circuit, or we say that the three resistances, they are connected in parallel when the uh, current, it gets divided, or different current will flow through these three resistances, right? So for a parallel circuit, the value of current flowing through each of these resistance will be different, but the value of voltage that appears across these three resistances will be the same, and it will be equal to your supply voltage, right? So for series resistances connected in series, the value of current will be the same, whereas voltage will be different across each of the resistances. Whereas for resistances in parallel, the value of current will be different and voltage will be the same, right? Now, to find the equivalent value of the resistance, or to find the total resistance of the circuit, we use this formula. Now this is slightly different. We take reciprocal of each of the resistance. So 1 over R1 plus 1 over R2 plus 1 over R3 will be equal to 1 divided by the total resistance. So let's find out the value for this particular circuit. So R1 is 3 ohms, R2 is 12 ohms, and R3 is 4 ohms. So let's apply this in the formula. So 1 over RT, let me use the stylus. So 1 over RT, it will be equal to 1 over R1 plus 1 over R2 plus 1 over R3. The value of R1 is 3 ohms plus the value of R2 is 12 ohms plus the value of R3 is 4 ohms. Now you can solve it the way you like. You can use your calculator, but I'm going to solve it this way. Right? I take the HCF, the highest common factor, and then 3 multiplied by 4 is 12. So 4 will come in the numerator. 12 is as it is. So it will be 1 plus, yeah, just checking the values. Now, this 4 multiplied by 3 is 12. So in the numerator, I'll have 3 like that. So 4, 5, 6, 7, 8. So 8 divided by 12, right? Now, the most common mistake, most of the student, they write this as their answer, right? So they write 8 divided by 1 over RT. It's not RT or your total resistance, right? So you have to take inverse of this. So if you are asked to calculate the value of total resistance for a parallel circuit, don't forget to invert the values over here, which you have got, right? So if we take the reciprocal of that, we'll get 12 divided by 8, right? 4 2s are 8 and 4 3s are 12. So it's 3 over 2 uh, or 1.5 ohms, right? So this will be the total resistance uh, of this circuit. Now, as I mentioned, for parallel circuit, the value of currents flowing through this will be different because your supply current, it gets divided in three parts, right? So in at the first junction, your supply current will get divided into two parts, into I1, which is flowing through resistance number 1, right? And the remaining current will then continue to flow. Then again at your second junction, again this current, whatever the leftover current, it will get divided again into two parts, right? So it will get divided into I2, and whatever is left, which is I3, it will flow through your resistance R3, right? So in that way, the current, it gets divided because you have two different paths or three different paths for the current to flow. So the current will get divided and different value of current will flow through each resistance. So, however, the voltage appearing across each of these resistances will be the same as I mentioned. Uh, Now, again, using Ohm's law, you can calculate the value of individual currents flowing through each of the resistance. The voltage will be equal to the supply voltage, Vs, right? And you already have the values of R1, R2, and R3. So you can calculate the individual current flowing through all these resistances. And again, if you add them up, it will be equal to your supply current. Okay, so that was pretty much everything that we discussed in the first lecture, right? Uh, so you can just go through all these topics again and maybe practice some questions on series and parallel circuit, and then using Ohm's law. And maybe if you get confused while converting the units, so you can practice some questions from the tutorial sheet or from the book which I have already mentioned, right? So you can find some questions over there. So that's it, let's end the class. uh, so see you in the next class. Thank you so much. Bye.